So welcome to the Mentored Engineer. In this video, we are going to look at designing IoT systems. All right, I'm joined here once again with Clay Counts, and we are going to talk about designing IoT systems. So Clay, my first question to you is, how many solutions can you provide that use basically off-the-shelf components and you don't have to do any customization of the hardware or software?
There's really a number of different applications that would be very what I consider off-the-shelf with our 370 device. If you're using, let's say, gate controls, that's a very easy off-the-shelf solution. Monitoring tank levels, temperature, humidity even would be an off-the-shelf solution that we could work with. There are custom type jobs that we do as well. So if somebody needs more Form C relays or more digital inputs, we could design a custom device for them, or more analog even. But as far as off the shelf goes, it really is, the sky's the limit. If you can think of it and it fits within our number of inputs and outputs, we can make it happen for you.
Excellent. So going along with that, if you decide, hey, I want an IoT system on such and such machine, how long does that take to really design and implement it?
Yeah, absolutely. So it really depends on the application. If you're monitoring temperature, doing something fairly simple, you can have it set up in a matter of minutes. You can have everything rolling, your login set up, everything ready to rock and roll in one day easily. If you're monitoring something a little bit more in depth, say like pressure on a gauge, things like that, it may take you a little bit more time, but it's got a very ease of installation, and the scalability is wonderful on these devices once you have your system set up. So once you get it going, it's very easy to add, increase your number of units from there.
Since we're on the topic, how do you plan ahead with a system and make sure that it's not going to be obsolete in 2 years?
Yeah, absolutely. And that's something that does make us a little unique at C-Level. We pride ourselves in long life availability of our products. If we make something, we don't want to make it for you for 1 year and then tell you 2 years later, hey, you can't use that anymore, or no, you can't buy another one of those, you got to buy our new system. We pride ourselves in making things for many years. As long as we can source the components, we'll make it for you. So from our standpoint, as long as you have sensors that will work with our device, which we make our device very capable of using other third-party sensors, then our device will work as long as possible. We do a lifetime warranty on our hardware, which we proudly stand by. So you can rest assured when you use a C-Level device, it's going to work for you for a very long time.
Excellent. So Clay, I want to ask you, what are the major cost drivers in an IoT system?
Yeah, in an IoT system, you have two major cost groups. You have your hardware costs, which will be the gateway, the IoT device, and then your sensors as well. And then you have your software recurring expenses. So if you have cellular, obviously you have to pay for the cellular usage in that case, and then as well the expenses associated with maintaining the cloud software. Then again, it all comes down to return on investment. If you're saving more money by using this as opposed to using, say, boots on the ground with technicians, sending people around, then obviously it makes sense to use an IoT device.
Excellent. So Clay, a lot of people have the mentality of we design and we try to identify failure points. A lot of us do design failure modes analysis, or DFMEAs. What are the major failure points of an IoT system?
Yeah, absolutely. So I can speak to C-Level's, our standard. We always back our hardware with a 100% lifetime guarantee. So if there was a failure of some sort, then we would gladly replace that for you. There are ISA cards that we made back in the early 90s that are still in use today. So we're very proud in the long life of our products. Most of the sensors we recommend whenever we work with a customer have a very long shelf life. Really, the concern is maybe damage from an outside source. If you had a voltage surge, or if you had something maybe come into contact with the device that could cause damage. But we have seen a very high success rate in our devices in the field. So there really isn't a single point that I could point to and say, hey, this is a major failure point, because we stand by our hardware and are very proud of it. But I could see, you could have some manufacturer's defects, things along those lines that could cause some issues. But again, we've had very high success with our hardware so far.
Okay. What about the software? As far as you have communication, you got software glitches and stuff like that. Is that?
Yeah. Yeah, absolutely. So software, the biggest concern on the software side of things is connectivity. So obviously you guys have all had your cell phone call drop. You've gone to try to send a text and it says no service. So that is a concern. If you don't have cellular connection in your area, then that can cause some problems with your IoT device communicating. Luckily, our device is able to wait and store small packets of data and push it to the cloud whenever connection resumes. So as long as you have some connection, you can usually work pretty well with our device.
Okay. What about redundancy? Is there any way to add hardware or cellular redundancy to these systems?
Yeah, that's a potential. In most applications that we work with, it's not been necessary in this case. But we've talked about doing edge computing devices where they talk about IoT on the edge or edge computing, where the end device has some computing capability, where it can store much more data, it can make decisions that are programmed to it on the end, so that if something happens, you lose connection, your device still operates in the way you designed and hoped it would.
All right. So let me ask you, when you're looking at a system, what is the difference between a well-designed system and one that's just or barely gets you by?
Yeah, absolutely. So I try to put myself in the customer's shoes and say, what do they want? They want something that works simple. They want support from us, and they want something that they can, get at an affordable cost and understand and come to us if they have any problems down the road. And I think we've done a very good job in our device. We've made it general enough that it can work with a number of applications, but we have enough I/O on the board that you can use it in a larger scale format. So when I think of a system that doesn't work very well, I think of something that's maybe closed, something that's very, very proprietary, whereas ours is very open-ended. We're happy to work with other people, work with third-party cloud platforms even, as long as they can communicate with our device.
Okay. So you mentioned open systems and closed systems as far as the cloud goes. Can you elaborate a little bit more on?
Yeah, absolutely. So from a high-level standpoint, open systems are more open-ended, more okay with working with third-party applications. Think of Android. Whereas a closed system, you can think more along the lines of Apple, who they only want their stuff to work with their stuff. We're very open at C-level because we understand the nature of industry. People use different things. They want to expand, change, grow. So we try to make our systems and all of our product lines very open-ended and able to use with a number of different interface options, number of different platforms, applications, just to make it easier on the end user.
Okay. What are some common mistakes that you see with people trying to implement IoT systems?
Yeah. So common mistakes are maybe not understanding what they're wanting to do or not understanding which data to collect, which is completely normal and understandable. You don't know what you don't know. There's things even I learn almost on a daily basis from our customers. They say, hey, this happened and we're doing this and we're seeing this, and hey, we're discovering this information we weren't expecting. And it's really just a wonderful, fun, exciting learning experience to be able to do every day, day in, day out here at C-level. Really, there's a number of things that people kind of learn along the way. It's really learn as you go when it comes to IoT.
All right. So as far as installation and implementation of, let's say, your product here, what are some design considerations that an engineer would need to look at before selecting either a location mount or what type of sensors they need to use?
Yeah, absolutely. So on our standard device here, the 370, this is the off-the-shelf solution that we use. It has our standard antenna, the flag antenna on it. We also have what I call our puck antenna with a 10-foot cable. So you can unscrew this and run this to a remote location further on top of the building outside the enclosure to improve your cellular connectivity. We also have an IP65 enclosure version that's used on the refrigerated trucks. So you can go in, they have their cable hooked up, which is also IP rated as well. Spray it down, clean out your trucks, make sure everything's good and clean, and don't have to worry about our device. So really it's kind of a experimental standpoint. Some people will plug with the flag in, their connection's great at their location, that's all they need. Some people run the flag to the top, and some people need the IP rated enclosure depending on what they're trying to do. But luckily we have a number of solutions here that we can work with you and find you a solution that'll work.
Okay. And for those listeners who don't know what IP is, it's a rating system for how a device will protect against dust intrusion or any type of object and water intrusion. So you'll have a number like IP67 or IP65, like you mentioned. The first number has to do with dust or object intrusion. And generally, a 6 is pretty standard for devices like this. And that means that pretty much dust can't get in there. An IP like a 00 would be, there's no protection. I can stick my finger right into it. And then as the numbers go up, they get further and further, smaller and smaller things can't go in them. With the water side, they have different tests for like if water can drip on it, if it can be sprayed from a low pressure hose, a high pressure hose. Once you get to 65, you can pretty much power wash it. So that would be the minimum I would recommend for any device that is outside. I think 66 and 67 are different levels of submerging the device in water, and it will still work.
Absolutely.
Okay. Well, that's all the questions I have for you today. I appreciate your time, Clay, and thank you for watching The Mentored Engineer. Thanks for watching this video. Please visit us at www.mentoredengineer.com and do a search for calculators. We have some phenomenal state-of-the-art calculators. Our team has worked so hard and we are so proud of these calculators. We have calculators for hydraulics, including pumps, motors, cylinders, and hoses. We have different pin calculators, and we have the ultimate beam calculator. So please go there, check it out, and sign up for your free 30-day trial.